In this video, we're going to take a look at how to solve quadratic equations by a process called completing the square. This is our third method that we can use to solve quadratic equations. So before we get started on how to solve quadratics using completing the square, let's just take a look at the process of completing the square. So in this example, it says find the value of k such that each expression is a perfect squared trinomial. So if you recall, a perfect squared trinomial means that our trinomial can factor into something like x plus some value squared, right? X plus some value squared. So it means that we have this linear term that is being squared. So we want to try and take this and figure out what value of k would make this possible. So let's take a look quickly at this x plus a quantity squared before we try and figure this out. So if I were to expand x plus a quantity squared into a trinomial, what would I get? So x times a, that's going to be x squared plus ax. And then if I were to multiply this out, I'm going to get plus another a times x plus an a squared. So combining my like terms gives me x squared plus 2ax plus a squared. Now, if we look at these and we try and equate some stuff, this term here is going to be equivalent to this, and this a squared is going to be equivalent to k. So if I can figure out a way to find a from this, I can then just square it to get this term. So what is the relationship between a in this 2ax and in the 22x? Well, we know this that both the x and the x are the same, so that means that the 22 has to equal 2a. Right? So 22 has to equal 2a, which means the value of a would have to be 11. So if a is 11, and from this it follows, right, then that means that k, right, k is a squared. That means that k would have to be 11 squared, which is 121. So really what this whole process shows us is sort of an algorithm that we can use in order to find this value of k. Essentially what you do is you take the coefficient of your middle term, divide it by 2, and square it. Right? So we took the coefficient of our middle term, divided it by 2 to get 11, and then we squared it to get this k value here. So what would that look like in this problem? So you take a look at your middle coefficient, your value of b. Remember, this is b in standard form. So that's going to be negative 12. We're going to divide that by 2, and then we're going to square that value to get k. So that's going to be negative 6 squared, which is 36. So in this situation, k is equal to 36, and that would give us a perfect square trinomial. Now, something that you might also notice, so we're told that a is here, and we looked at this there, right? We looked at this binomial squared to try and figure out these values of a and k. So this tells me then that what we have here, if this was 121, this would factor to be x plus 11, that quantity squared. So this then, right, if this was 36, would factor to be x, and then you take this value of a is just what we get here. It's just the b value divided by 2. So then this would be x minus 6 quantity squared. And if you went through the process of doing your factoring and all of that, you'd see that this holds. Okay? So this whole process that we just talked about is called completing the square. So this process is called completing the square. And we can use it to solve quadratic equations. Now, it can't solve all quadratic equations. It solves them for a very specific form. And it solves quadratic, again, we're talking about quadratic equations. These are just expressions. So there's going to be an equal sign in these. But these quadratic equations will be in the form of x squared plus bx equals c. So if you remember, standard form equation for a quadratic looks like this. Ax squared plus bx plus c equals 0. So if you're comparing these two, we'll notice that the a value is 1, right? So when there's not really a coefficient there, it's an implied 1. B is over here, so the terms with x's are on the left, and then we moved this c to the other side. So really it should be the opposite of what it would be on the left side. But it has to be in this form, leading coefficient of 1, and then you need your constant on the other side. If not, we can move it. Now, to be able to actually go through the process of solving, we have to complete the square on the left side. So to do that, we took the b divided by 2 and squared it. And we know that anything you do to one side of an equation has to be done to both. So we have to add b over 2 quantity squared to both sides of our equation. Then once we've added this, we're going to factor. And we know that it factored into something like x plus the middle term divided by 2, that whole quantity squared. But on the right side now, we took this c and we added this b over 2 squared. So we have this on the right-hand side. Now this is just going to be a number, right? C is a constant, b was the coefficient, so this is just going to turn out to be a number. So that can probably be put together and simplified. So once we've done that, then we can just solve this. So the way that we solve this, when you have some quantity squared, the inverse operation of squaring something is taking the square root. So we will just take the square root of both sides. And if you recall from our last video, right, anytime you take the square root of our constant, we have to introduce the plus or minus. So take the positive and negative square root of our constant. Then we would go through the process of isolating the variable and simplifying if necessary. Okay, so let's try and do this full process for a problem. So in this problem, we're asked to solve by completing the square. If there's no solution, write no solution. So is this in the form that we need? Well, yeah, the leading coefficient's 1. We have the a and bx over here and c on the right. So what we need to do for this then is take the middle term, right? So actually, I'm going to rewrite this and give myself a little bit of space. So we're going to say x squared minus 6x equals 247, because I know I need to add something in here, right? So the value that gets added in here is going to be negative 6 divided by 2. So you take your middle term divided by 2 and square it. So that's going to be negative 3 squared. Negative 3 times negative 3 is positive 9. So we're going to be adding in this 9. And remember, anything you do to one side has to be done to both. So the left side now is a perfect square trinomial. It factors into some quantity squared. Now, if you didn't remember the trick, right, so we know that it factors to be x plus or minus the value of b over 2. b is negative 3, so it's going to be, or sorry, b over 2 is negative 3, so it'll be that, equals, and then this sum, 256. Now, if you didn't remember this trick, you could just do the factoring process, right? So what multiplies to be positive 9 and adds to negative 6? Back sign is positive, middle sign is negative, that means it's two negatives. Negative 3 and negative 3. Since the leading coefficient is 1, that tells us we can jump straight into our factors of x minus 3 and x minus 3. And we know when we have the same quantity multiplying itself twice, it turns out to be squared. So we get something like that. Okay. So now, to solve this, since this is being squared, we need to undo that by taking the square root of both sides. And remember, anytime you're taking the square root of this constant, we need to take the positive and negative square root. We are not just looking for the principal root. So when you take the square root of something squared, you get just the argument, so just what's being squared as a result. So we get x minus 3 equals positive and negative. 256 is a perfect square. It's 16 squared, so we get plus or minus 16. Okay, so now from here, what does this tell me? This is really telling me I have two equations. You have two equations. So from this, I'm getting that x minus 3 is either positive 16 or x minus 3 is negative 16. So now I have these two equations that I need to solve. So I'm going to add 3 to both sides. And I'm actually going to do that in both of these, add 3 and add 3. And the result that I get, 16 plus 3 is 19, so that's my first result. And then negative 16 plus 3 is going to be negative 13. So my two solutions are 19 and negative 13. Now, if you recall, solutions basically just represent where your graph crosses the x-axis, right? So if we had our graph that looked like this, we'd have a point over here that would be like x equals negative 13. We'd have this point there that would be like at x equals 19. And that's what our solutions represent. Some other names for solutions that you might experience are something like x-intercepts, because again, it's where it crosses the x-axis. You might hear them called zeros or roots. So just know that if you ever hear them called solutions, intercepts, or x-intercepts, zeros, roots, they're all talking about the same thing. Okay, so let's try this example. In this example, we are not quite in the form that we need. We have this value of c here on the left side with the rest of our stuff. This is in standard form. So we need to move this 36. So we're going to subtract it from both sides. So we're going to move it over, and we're going to give ourselves this, x squared plus 20x. And I'm going to leave that space there where the 36 was, because I know that I have to go in and add something. So I'm going to have to add something in here. So remember, the process is take the middle term, its coefficient, divide by 2, and then square that. So 20 divided by 2 is 10. 10 squared is 100. So I'm adding 100, and if I add it to the left, I have to add it to the right. And that gives me this perfect square trinomial. It factors to be x, and then this value, right, of b divided by 2, it's positive, so plus 10 quantity squared equals, what is negative 36? Negative 36 plus 100. I think that's 64. Okay, so now take the square root of both sides. Take the square root. I'm going to go like this. Then plus or minus square root there. And again, we got pretty lucky. This is a perfect square, so it's plus or minus 8. And then we get that x plus 10 equals that. So again, remember, this gives us two equations. I'm going to move this over here. Now, sometimes you can also see this written in this way. So if I were to subtract 10 from both sides, one thing that you have to be careful about is I can't just put these together right now. I can't say it's plus or minus negative 2. What this would end up looking like is x equals negative 10 plus or minus 8. And then from here, I can look at my two different equations, plus or minus 8. So from this, I would get that x equals negative 10 plus 8, or x equals negative 10 minus 8. Now, this is important, not necessarily in this step, but in some future problems that we're going to look at. So what is negative 10 plus 8? That's going to be negative 2. Negative 10 minus 8, you can think of that as adding a negative. So it's getting more negative, so that would be negative 18. Now, what this is telling me, actually, so in this problem, I got integer answers. In this problem, I got integer answers. They're rational. What this actually tells me is that my original equation was factorable. I could have factored my original equation. But because it told us to solve by completing the square, that's the method that I used. So if I wanted to factor this to solve, I could do that. And this would be the right form to factor to solve. But we can't always factor, and that's why completing the square can be nice at times. So let's take a look at this one. Now, the left side is actually factorable. I could factor the left side. If I factored the left side, it would end up being x minus 9 times x plus 1 equals 3. Now, when we were trying to solve by factoring, we didn't have a 3 product property. It was called the 0 product property. There's no rule that tells us when I have two factors that multiply to be 3, one or both have to be 3, right? That doesn't work. We don't have that rule. We have the 0 product property. And so just because the left side is factorable doesn't mean we can use factoring. This one ultimately is not going to be factorable, so we're going to use completing the square. So to complete the square, I need to move this 9. So let's add 9. So adding 9 gives me x squared minus 8x equals 12. Equals 12. Okay, so take the middle term, take the value of b, divide by 2, and square. So negative 8 divided by 2, that's negative 4. Negative 4 squared is positive 16, right? A negative times a negative. So we're going to add 16 here. Plus 16. So what do I end up with? I get x squared. Oh, wait. Actually, I can just jump straight to the factoring here, right? So I know that this factors to be what? Well, I take my b divided by 2 and I put it into my binomial. So it's going to be x minus 2 quantity squared equals 12 plus 16. That is 28. Okay, so let's go ahead and take the square root of both sides. Remember, it's going to be plus or minus here. And taking the square root of a quantity squared gives me just that quantity. So it's going to be x minus 4 equals the square root of 28. Is it a perfect square? It is not. Okay, so we have to do a little bit of simplifying. So 28, that is 4 and 7, 2 and 2. This has an index of 2, so we're looking for a pair. So this is going to be plus or minus 2 times the square root of 7. 2 times the square root of 7. So that's what the square root of 28 is. It's 2 times the square root of 7. So let's go ahead and take a look at what these solutions would end up being. So if I add 4 to both sides, I'm going to get x equals. Now I can't combine these. The 4 and the 2 rad 7, they're not like terms, they're not like radicals, so they actually can't be combined. So this is where that format that I was showing you before in that last problem kind of comes into effect and is handy. So we have this, x equals 4 plus or minus 2 rad 7. And actually, I am 100% okay if you leave your answer like this. Leave your answer like that. But what does it mean? What does it mean? It means x is either 4 plus 2 times the square root of 7, or x is 4 minus 2 times the square root of 7. So those are your two solutions for this. But this is an acceptable way to write your solution because this plus or minus here is telling me we have two different answers, the positive form and the negative form. Okay? All right, so let's look at our last example here. This is our last one. Let's go with this. So we have x squared plus 6x plus 25 equals 0. So we know to complete the square, this has to be moved over. So to do that, I'm going to subtract 25. Subtract 25. So we have x squared plus 6x equals negative 25. Let's go ahead and take the middle term, divide by 2. So it's positive 6 divided by 2 squared. So that's going to be positive 3 squared is 9. So I'm going to add 9 to both sides. And then we can factor. So I know that this left is a perfect square trinomial now. It factors to be x and then this value, right, plus 3 squared. And the right side, negative 25 plus 9, 25 minus 9, that's positive 16. We take the sign of the larger, so it's negative 16. So now take the square root. Take the square root. We know it has to be plus or minus square root there. We know the left side would result in being x plus 3. And what's the square root of negative 16? Is there any number that multiplies to be number that multiplies by itself to be negative 16? Well, no. There's not a real number that multiplies to be this. So because there's this negative inside our radical, this tells me we have no solution. So this is the situation that you're looking for when you have no solution, right? If there's no solution, it's when you have a negative in your radical like this. So this ends up actually being just no solution and will not have a value. Okay? So this is the process for completing the square. If you guys have questions, feel free to reach out to me. All right, good luck.